The silence of the interstellar medium is not merely the absence of sound, but a profound and heavy weight, a state of existence where the very concept of vibration has been extinguished by the vastness of the dark. Through this frozen expanse, a singular phantom lens drifts, a silent sentinel carved from the collective curiosity of a species still tethered to a small damp rock billions of miles behind. Here, the temperature hovers at a mere few fractions of a degree above absolute zero, the point where all molecular motion ceases and the universe becomes a static, unmoving portrait of the void. There is no wind, no breath, only the slow, rhythmic pulse of distant pulsars and the cold, indifferent glow of 100 billion suns scattered across the velvet blackness of the Milky Way. The observer moves toward a region of space that should be empty, a pocket of the vacuum where the laws of celestial mechanics suggested nothing of consequence could endure. Yet, as the distance closes, a silhouette begins to resolve against the backdrop of the galactic core. It is a shape that defies the elegant symmetry of our own planetary neighbourhood. It does not hang in the comfortable wide orbits of the giants we know, nor does it sit in the temperate cradle where liquid water might cling to its surface. Instead, it is a jagged shadow, a dark blemish against the starlight, positioned so close to its parent sun that the two bodies appear locked in a desperate lethal embrace. As the observer rounds the curve of the planet's dark side, the first glimpse of a sunrise breaks across the horizon, but it is a sunrise that defies the very definition of the word. In our world, dawn is a soft transition, a gradual bleeding of gold and blue through a protective veil of nitrogen and oxygen. Here, there is no such mercy. The light does not rise, it erupts. It is a violent, screaming torrent of ultraviolet and X-ray radiation that tears through the thin, tattered atmosphere like a blade through silk. The horizon is not a gentle curve, but a fractured, jagged edge where the vacuum of space meets a wall of incandescent vapour. The light is so intense that it transcends colour, becoming a blinding, monochromatic force that threatens to dissolve the very matter it touches. This is the first moment of a profound and crushing cosmic dread. It is the realization that the familiar order of our own solar system, the neat circular orbits, the predictable seasons, the quiet stability of the planets, is not the standard by which the universe operates. We have lived our entire history under a thin veil of celestial tranquility, believing that the architecture of our home was the blueprint for all others. We saw the giants in the outer dark and the rocky inner worlds, and assumed we understood the rules of the game. But as this impossible world comes into focus, that veil is stripped away, revealing a chaotic and indifferent reality where planets are not born into peace, but forged in a crucible of madness. The world below is a testament to that chaos. It is a place where the laws of planetary formation, as written in the ink of our early textbooks, have been discarded and burned. We once believed that gas giants could only exist in the frozen reaches of a system, far from the heat of their stars where ices could coalesce and gravity could gather the thick blankets of hydrogen and helium. Yet, here stands a titan, a world massive and bloated, dancing so close to the fire that its outer layers are being stripped away in a shimmering tail of plasma that stretches for millions of miles into the void. It is a hot Jupiter, a celestial anomaly that should not exist according to the old logic, yet it dominates the sky with a terrifying, majestic presence. The observer watches as the planet's surface, if it can be called that, roils under the relentless bombardment of its master. The atmosphere is a churning cauldron of vaporized rock and metallic mists, driven by winds that move at thousands of miles per hour, far exceeding the speed of sound. There is no solid ground here, only a transition from a screaming, superheated gas to a crushing, supercritical fluid that is neither liquid nor air. The heat is so extreme that the very molecules of the atmosphere are torn apart, their constituent atoms ionized and flung into space by the pressure of the starlight. It is a world in the process of being unmade, a planetary ghost that is being consumed by the very star that gave it birth. This sight forces a revaluation of everything we thought we knew about our place in the cosmos. We are forced to confront the possibility that we are the outliers, the rare survivors of a cosmic lottery that usually favours the violent and the extreme. The quiet clockwork of the Earth and its siblings is a fluke of gravity and time, a momentary pause in a universe that more often produces nightmares of iron rain and glass winds. The sense of isolation deepens as the observer realizes that, across the billions of stars in this galaxy, there are millions of worlds like this one. Worlds of fire, worlds of ice, worlds where the very air is a poison and the light is a death sentence. The Sentinel continues its drift, a tiny spark of consciousness in an ocean of radiation. It records the data of a world that refuses to be categorized, a world that stands as a harbinger of the true nature of the universe. The dread is not just for the fate of this doomed planet, but for the fragility of our own understanding. We have looked into the abyss and found that the abyss is not empty. It is filled with monsters of our own making, celestial bodies that challenge our arrogance and remind us that we are guests in a house that was not built for us. The impossible sunrise continues to burn, a white-hot reminder that in the grand tapestry of the infinite, the only constant is change, and the only certainty is the eventual dissolution of all things under the weight of an indifferent sun. Before the dawn of the 17th century, the boundaries of the cosmos were thought to be fixed and immutable, a series of crystalline spheres nesting the earth at the centre of all creation. But in the year 1600, in the heart of Rome's Campo de' Fiori, a man named Giordano Bruno was bound to a stake, his voice silenced by a metal vice, and his body surrendered to the flames. His transgression was not merely a denial of dogma, but a vision of such terrifying scale that it threatened to dissolve the very foundations of the human story. Bruno looked at the night sky and did not see cold, distant lanterns fixed to a celestial ceiling. He saw an infinite expanse. He proclaimed that every star was a sun, a gargantuan engine of fire identical to our own, and that around these countless suns revolved an infinity of other Earths, populated by beings as diverse as the stars themselves. To Bruno, the universe was a cathedral of infinite worlds, a boundless sea where the divine was not a distant judge, but the very breath of an endless living architecture. When the smoke of his execution cleared, a long and heavy silence descended upon the heavens. For nearly 400 years the stars remained lonely sentinels, beautiful but seemingly barren. Even as the Enlightenment dawned and the telescopes of the 19th century grew in power, resolving distant nebulae into vast islands of stars we now call galaxies, the planets remained hidden in the glare of their masters. Science settled into a comfortable, if somewhat arrogant, assumption. It was believed that the formation of a solar system was a freak accident of nature, a 1 in a billion collision of circumstances that had occurred here in our quiet corner of the Milky Way, and perhaps nowhere else. We looked at the void and saw an elegant empty desert, convinced that our own family of planets represented the only jewels in the dark. We were the protagonists of a solitary drama, convinced that the laws of physics that had shaped our world were the only ones that mattered. This quietude persisted until the final decade of the 20th century, when the technological reach of humanity finally began to catch up with the intuition of the martyred friar. In the year 1995, atop a sun-drenched plateau in southeastern France, the Haute-Provence Observatory became the site of a quiet revolution. Two astronomers, Michel Mayor and Didier Queloz, were not searching for a visual confirmation of a distant world, for the light of a planet is drowned out by the brilliance of its star like a firefly hovering next to a coastal lighthouse. Instead, they were hunting for a ghost in the light. Using a spectrograph of unprecedented precision known as LED, they monitored a star known as 51 Pegasi, a yellow dwarf located some 50 light-years from our own sun. They were searching for a wobble, a rhythmic tug-of-war between a star and an unseen companion. According to the fundamental laws of motion, a planet does not simply orbit a star, rather, both bodies orbit a common centre of mass. As a massive planet swings through its path, its gravity pulls its parent star slightly toward it, then away, causing the star's light to shift toward the blue end of the spectrum as it approaches the observer and toward the red end as it recedes. For months, the data from Haute-Provence whispered a story that seemed to defy every rule in the astronomical handbook. The shifts were too fast, the tugging too violent, and the frequency too rhythmic to be a mere error in the instruments. The mathematics revealed a world that should not have been possible. It was a giant possessing at least half the mass of Jupiter, yet it was orbiting its star at a distance so close that it completed a full revolution in just 4 days. In our own system, Mercury, the scorched messenger, takes 88 days to round the Sun. This new world, 51 Pegasi b, was dancing in the very fires of its master, its atmosphere bloated by a heat that reached over 1,000 degrees Celsius. This was the first hot Jupiter, a celestial anomaly that shattered our solar-centric arrogance in a single stroke. It proved that the architecture of our own neighbourhood, with small rocky worlds near the Sun and gas giants in the frozen outer reaches, was not the universal blueprint. The discovery rippled through the scientific community like a shockwave. If such a strange and hostile world could exist, then the variety of the cosmos was likely far beyond anything we had dared to theorize. The realization was both exhilarating and humbling. We were forced to admit that our understanding of planetary formation was a fragile mask over a much more chaotic reality. Giordano Bruno's vision had been vindicated, but the reality was far stranger than even he had imagined. The cathedral of infinite worlds was real, but its aisles were filled with monsters, worlds of fire and iron that challenged our definitions of what a planet could be. We were no longer the centre of the plane, nor were we the standard by which the universe measured its creations. We were merely one small, quiet sanctuary in a galaxy teeming with impossible nightmares, a single note in a symphony of cosmic violence that was only just beginning to be heard. The announcement of 51 Pegasi b in October of 1995 rippled through the halls of the International Astronomical Union meeting in Florence like a heresy whispered in a cathedral. The data presented by the Swiss team did not merely suggest a new planet, it described a physical impossibility according to every established model of the time. The scientific community recoiled in a state of collective cognitive dissonance. For decades, the search for exoplanets had been predicated on the assumption that other solar systems would mirror our own, with small rocky worlds huddled near the warmth of the star and massive gas giants relegated to the frozen distant outskirts. But here was a behemoth, a world at least half the mass of Jupiter, completing a full journey around its sun in just over 4 terrestrial days. Confusion quickly curdled into skepticism. Many researchers argued that the rhythmic wobble detected in the light of the star was not a planet at all, but perhaps a pulse in the stellar atmosphere or a misinterpretation of a binary star system viewed from a deceptive angle. The idea that a gas giant could survive, let alone form, in such a hellish proximity to its parent sun was seen as a failure of the mathematics. According to the core accretion model, the reigning theory of planetary birth, a planet of that magnitude required the cold temperatures of the outer system to gather its thick envelope of hydrogen and helium. In the searing heat of the inner system, the solar winds should have stripped away such light gases before a planet could ever take shape. Yet the data remained stubborn, recalcitrant, and undeniably real. The physical presence of 51 Pegasi b is a vision of celestial violence. It is a bloated titan, its radius expanded by the relentless thermal energy of a sun that looms nearly 10 times larger in its sky than our sun appears from Earth. This world exists in a state of permanent roasting, its upper atmosphere reaching temperatures exceeding 1,000 degrees Celsius. At such heat, the very chemistry of the planet begins to shift. It is not the cold, banded world of our Jupiter, but a glowing, distended orb of incandescent gas. The proximity to its master is so extreme that the planet is likely tidally locked, with one face eternally subjected to the unblinking stare of the star, while the other remains in a state of permanent superheated shadow. The gravitational relationship between the star and this world is not a gentle orbit but a brutal tug-of-war. The star's immense gravity exerts tidal forces so powerful they knead the planet's interior, generating even more heat through internal friction. This is a world dancing on the absolute edge of destruction, its outer layers constantly being buffeted by a torrential stream of charged particles. It is a planetary sacrifice, a giant being slowly consumed by the radiation of the very entity that keeps it in its grip. The realization that such a world existed forced a total and immediate revision of the solar-centric blueprint that had governed human thought for centuries. Before 1995, we viewed our solar system as the gold standard of cosmic architecture. we believed the orderly progression from Mercury to Neptune was the natural result of physical laws that were universal and invariant. We saw ourselves as the logical outcome of a stable, predictable process. But 51 Pegasus IB shattered that comfort. It suggested that our quiet, orderly neighbourhood, where the giants stay in their place and the rocky worlds are allowed to cool, might be a rare and peculiar exception. We began to see that the universe does not favour stability. It favours diversity, often through the most extreme and chaotic means imaginable. The discovery of this first hot Jupiter was the opening of a floodgate. It taught us that planets are not static objects that remain where they are born, but dynamic entities that can move, migrate, and transform. It revealed that the frost line, once thought to be an impassable wall for gas giants, was merely a suggestion that the universe frequently ignores. This single, wobbling star in the constellation of Pegasus forced us to confront a terrifying new reality. We are living in a galaxy where the rules we wrote in our textbooks are being broken in every corner of the dark. We are not the blueprint. We are perhaps a momentary lull in a much more violent and unpredictable storm of creation, a single quiet harbour in a sea where giants roam the shallows and worlds are forged in fires that should have consumed them. The formation of a planetary system begins not with a bang, but with a whisper of gravity acting upon a cold, dark cloud of molecular hydrogen and ancient stardust. This cloud, spanning light years of the void, eventually reaches a point of critical density where its own mass becomes its master. It begins to collapse, falling inward upon itself with an inevitability that defies the resistance of the vacuum. As the centre of this collapse grows dense and hot, igniting the first fires of a protostar, the remaining material is spun into a vast flattened disk of debris. This is the protoplanetary disk, a swirling incandescent arena where the future of every world is decided. It is a chaotic ballet of dust and gas, a place where trillions of microscopic grains of silicate and iron dance in a storm of radiation and kinetic energy. Within this roiling disk, the silent architect of gravity works with a relentless, crushing grip. Grains of dust no larger than the soot from a candle collide in the darkness. Through the subtle pull of electrostatic forces, they begin to cling together, forming larger clusters that eventually grow into pebbles, then boulders, and finally into the jagged kilometre-wide seeds of worlds known as planetesimals. This is a process of extreme violence and unceasing motion. The disk is crowded with these primordial fragments, each one a projectile moving at thousands of miles per hour. They do not merely orbit, they collide, they shatter, and occasionally they merge. It is a war of attrition where only the most massive survive, consuming their neighbours to grow ever larger in a cycle of celestial cannibalism. As the young star at the centre begins to roar with the energy of nuclear fusion, it casts a long thermal shadow across the disk. This creates a profound temperature gradient that dictates the very chemistry of the worlds to come. Close to the stellar fire, the heat is a relentless scythe, vaporizing volatile compounds like water, methane, and ammonia into an invisible mist. In this searing inner sanctum, only the most resilient materials, metals, and rocky silicates can remain in a solid state. This is why the inner planets of a typical system are small, dense, and rocky. They are forged from the meagre leftovers that could withstand the heat. Beyond this inner circle lies an invisible but absolute frontier known as the frost line. This is the boundary where the temperature of the disk finally drops low enough for water vapour to crystallize into solid ice. The crossing of this line changes everything. Suddenly, the amount of solid material available for planetary growth increases by a factor of 10. These icy grains act as a cosmic glue, allowing planetary cores to swell with a speed and ferocity that is impossible in the inner system. Once a core reaches a mass roughly 10 times that of the Earth, its gravitational reach becomes so profound that it begins to snatch the surrounding hydrogen and helium gas directly from the disk. This is the birth of the giants, bloated, gas-shrouded titans that dominate the cold, dark reaches of the outer system. The standard models of physics once described this process as a masterpiece of predictable logic. We wrote textbooks that spoke of the core accretion model as an immutable law, a set of rules that guaranteed an orderly universe. These rules dictated that a gas giant could never form near its star because the raw materials required for its massive core simply could not exist in the heat. It was a theoretical beauty that suggested a universe of clean lines and distinct zones, where every object knew its place and remained there for billions of years. We looked at our own solar system and saw a clockwork mechanism, a perfect proof of our own mathematical elegance. However, this perceived order was a mask for a much more volatile reality. The tension between the theoretical beauty of our laws and the messy, violent truth of planetary birth is the space where the monsters are made. The protoplanetary disk is not a static ring, but a fluid, turbulent sea of plasma and gas. The very gas that feeds the giants also exerts a drag upon them, creating a friction that can sap their orbital energy. The rules of physics are not a set of rigid tracks, but a complex interplay of forces that can drive a world to spiral inward, dragging it through the very regions where it was told it could never exist. The ballet is not one of graceful, distant pirouettes, but of gravitational tugs of war that can throw entire worlds into the sun or cast them out into the eternal night. We are realizing that the frost line is not a wall, but a shifting shadow, and the crucible of creation is a place where the rules are broken as often as they are followed. The neat circular orbits of our own home are not the inevitable result of physics, but perhaps a rare and lucky outcome of a process that more often results in a celestial storm of migration and destruction. The young giant, bloated with hydrogen and helium, does not find a permanent sanctuary in the icy reaches beyond the frost line. Instead, it finds itself trapped within the very material that gave it life. The protoplanetary disk is not a passive ring of dust, but a dense, swirling ocean of gas and plasma that exerts a relentless influence on everything within its grasp. As a massive world moves through this medium, it acts as a gravitational anchor, creating ripples that radiate outward like the wake of a great ship. These are spiral density waves, structures of concentrated gas that begin to exert a subtle but lethal torque on the planet itself. This is the physics of gravitational friction, a silent thief of momentum that begins to tug at the giant, forcing its wide, circular path to tighten into a lethal inward spiral. The planet becomes a predator in a primordial sea, moving through the disk with a slow, grinding inevitability. It is no longer a static observer of the system's growth, but an active agent of transformation. As it loses its orbital energy to the surrounding gas, it leaves its cold birthplace and begins a journey toward the inner fires of the star. This migration is not a peaceful transition. It is a march of total architectural upheaval. The interaction between the planet and the gas disk is a complex feedback loop. The planet carves a wide gap in the disk, and the edges of this gap push back with immense force. The inner edge of the gas tries to push the planet outward, while the outer edge pushes it inward. In the dense, high-pressure environments of a young system, the outer edge almost always wins this gravitational tug-of-war. The resulting loss of angular momentum is absolute. The planet has no choice but to fall. The giant, possessing the mass of hundreds of Earths, possesses a gravitational field that acts like a scythe. Any smaller rocky bodies, the embryonic versions of worlds like our own, that happen to lie in its path are faced with a binary fate. They are either consumed by the encroaching titan or flung violently out of the system. In the wake of this migrating monster, the carefully organized zones of the solar system are shattered. The inner regions, once the quiet domain of silicate dust and rocky planetesimals, are suddenly invaded by a gravitational force they cannot withstand. As the giant plunges inward, it scatters these smaller bodies like leaves in a gale. Some are hurled into the sun, where they are vaporized in an instant, their chemical signatures lost forever to the stellar furnace. Others are accelerated to such extreme velocities that they are cast out into the interstellar void, destined to wander the darkness as rogue planets, forever severed from the light and warmth of a star. In a matter of only a few million years, a mere heartbeat in the life of a galaxy, the entire structure of the planetary system is rewritten. What was once a potential home for a dozen diverse worlds is compressed, distorted, and cleared of its original inhabitants. The destruction is not limited to the rocks. The gas itself is funneled and churned, creating a secondary disk around the migrating planet. This circumplanetary disk can become a site for the birth of massive moons. which are then themselves subjected to the same stresses as their parent world. It is a fractal of chaos, where every scale of existence is touched by the violence of the migration. This process of migration explains the existence of the anomalies that first baffled the observers at the end of the 20th century. The hot Jupiters were not born in the heat. They are refugees from the outer dark, survivors of a journey that should have been impossible. They are the winners of a brutal cosmic lottery, having moved from the frozen reaches to the very edge of the stellar atmosphere without being entirely consumed. This movement reveals a universe that is far more fluid and dangerous than our ancestors ever dared to dream. It suggests that the positions of the planets are not fixed by divine decree or immutable law, but are the result of a chaotic struggle between gravity and friction. The realization of planetary migration forces a terrifying conclusion. Our own solar system may have narrowly avoided this fate, or perhaps we are the survivors of a similar, though less extreme, migration event. There are theories that suggest our own Jupiter once began this inward march, only to be pulled back by the gravitational influence of Saturn in a celestial dance known as the Grand Tack. Had that second giant not been there to provide a counterbalance, our Jupiter might have continued its descent, clearing the inner solar system of the very material that eventually formed the Earth. We exist because a giant stopped its hunt, leaving a small pocket of stability where life could eventually take root. But in countless other systems across the Milky Way, the predator did not stop. It moved all the way to the centre, becoming a scorched sentinel in the impossible night. These systems are the graveyards of rocky worlds, places where the architecture of the cosmos has been simplified into a single, bloated survivor and its starving star. The legacy of migration is a galaxy filled with these lonely, displaced giants, serving as a testament to the fact that in the crucible of creation, the only law is change, and the only constant is the motion of the heavy and the hungry. The silence that follows such a migration is not the silence of peace, but the silence of a desert, where the only thing left to move is the screaming wind of a world that was never meant to be there. The clockwork of the cosmos usually moves with a stately ancient grace, but at the absolute frontier of planetary existence, the rhythm of time is compressed into a frantic and lethal blur. There exist worlds that have migrated so far into the gravity well of their masters that they complete a full revolution in less time than it takes for a human to sleep through a single night. In these systems, the concept of a year has lost all meaning, replaced by an orbital period measured in a mere 8 or 10 hours. This is the realm of the ultra-short period planet, a place where a world is essentially skimming the outer atmosphere of its star, moving at hundreds of thousands of miles per hour just to stay aloft against the crushing inward pull of the stellar furnace. These planets are the ultimate survivors of the migration process, having halted their inward plunge just before crossing the point of no return where tidal forces would tear them into a ring of glowing dust. From the surface of such a world, if the word surface can even be applied to a realm of liquid fire, the parent star does not appear as a distant disk in the sky. It is an all-consuming wall of white-hot plasma that occupies nearly half the celestial sphere. The radiation is so intense that it does not merely heat the planet, it flays it. The electromagnetic bombardment is constant, a torrential rain of high-energy particles that would strip away a conventional atmosphere of nitrogen or oxygen in a matter of a few centuries. But this world has replaced its lost gases with something far more alien and terrifying. The air here is not composed of the breaths of a life, but of the very bones of the planet itself. The heat on the day side reaches temperatures of 3,000 degrees Celsius or more, a threshold where the very stones begin to scream. Silicates, magnesium, and iron, the fundamental building blocks of terrestrial crusts, do not remain solid under this relentless onslaught. They melt, then they boil, and finally, they evaporate into the sky. The atmosphere is a thick, shimmering haze of mineral mists and vaporized rock. Clouds are not made of water droplets, but of liquid droplets of sodium and calcium, suspended in a caustic, glowing fog. When these mineral vapors rise into the slightly cooler upper layers of the atmosphere, they do not fall as life-giving rain, but as a searing grit of solidified stone, a hailstorm of rubies and sapphires forged in the heart of a furnace, and cast down upon a world that is already liquid. Below this silicate sky, the crust has long since surrendered to the heat. There is no continent, no mountain, no valley, only a global, roiling ocean of magma that covers the entire illuminated hemisphere. This is the molten eye of the planet, a vast, lidless iris of liquid stone that stares forever at the sun. The currents in this magma sea are driven by the same tidal forces that keep the world in its tight, frantic orbit. Massive waves of molten basalt hundreds of feet high surge across the surface, driven by the gravitational kneading of the star. It is a world in a state of perpetual liquefaction, where the boundary between the mantle and the atmosphere is a chaotic, blurred zone of boiling stone and incandescent gas. The very ground is a fluid, shifting and churning in response to the solar winds that lash the surface. The physical presence of the star is so dominant that its light exerts a literal, mechanical pressure on the planet's atmosphere. The solar wind acts like a physical broom, pushing the mineral mist toward the night side in a continuous supersonic stream. This creates a permanent tail of glowing gas, a planetary comet trail that makes the world look like a bleeding wound in the dark. The planet is being slowly vaporized from the outside in, its mass being fed into the star atom by atom, second by second. It is a testament to the absolute limit of what a planet can be before it is simply erased from existence. Every hour that passes is a struggle against total dissolution, a frantic race to maintain an orbit that is slowly but surely decaying. To look upon such a world is to witness a paradox of physics. It is a planet, yet it possesses none of the qualities we associate with planetary stability. It is a rocky world, yet it is liquid. It has an atmosphere, yet that atmosphere is a poison of vaporized minerals. It exists in a state of terminal equilibrium, balanced on a knife edge between the centrifugal force of its incredible speed and the inward pull of a star that is actively consuming it. This is the kingdom of the impossible, a place where the laws of geology and meteorology merge into a single, terrifying discipline of high-energy physics. Here, the universe demonstrates that it can take the most solid and dependable materials, the very rocks we walk upon, and turn them into a ghost, a shimmering, molten remnant of a world that dared to venture too close to the light. The silence of this place is filled with the roar of the stellar wind and the hiss of evaporating stone, a sound that marks the slow, agonizing death of a celestial body. This death is accelerated by a phenomenon of gravitational synchronization known as tidal locking, a state where the planet's rotation has been ground down by the relentless pull of the star until one side is forever enslaved to the light. In this configuration, the planet no longer spins relative to its master. It simply orbits like a moon, presenting the same scorched face to the stellar fires for eternity. This creates a world of two absolute and irreconcilable extremes, a celestial body divided into two eternal hemispheres that exist in a state of permanent violent opposition. One half of the world is a perpetual furnace, a realm of unblinking radiation where the sun never sets, while the other is a tomb of absolute ice, a Stygian wasteland where the stars are the only source of light, and the temperature drops toward the very floor of physics. The day side is a landscape of incandescent ruin. Under the unmoving glare of a sun that may appear 30 or 40 times larger than our own, the surface is subjected to a constant bombardment of thermal energy. The rocks do not merely heat, they undergo a phase transition. Basalt and granite soften into a viscous sludge before turning into vast, roiling oceans of magma. The atmosphere above this hemisphere is a thick, choking haze of vaporized minerals, where the very air is heavy with the weight of gaseous iron and silicon. There is no relief, no shadow, and no respite. The heat is so pervasive that it penetrates deep into the planetary mantle, keeping the interior in a state of perpetual liquid unrest. Diametrically opposed to this inferno is the night side, a place where the concept of heat is a distant, forgotten memory. Because the planet does not rotate, no warmth from the star ever reaches this hemisphere through direct radiation. The only heat that arrives is carried by the gasping remnants of the atmosphere as it spills over the horizon. In the absence of this circulation, the night side would reach temperatures of nearly 270 degrees below 0 Celsius. Here, the very gases that make up the atmosphere, nitrogen, carbon dioxide, and perhaps even oxygen, begin to freeze. They do not merely condense, they snow out of the sky, forming vast, crystalline glaciers of frozen air that wrap the dark side in a shroud of lethal, translucent ice. It is a world of silent, frozen mountains and plains of solidified gas, stretching out into a darkness that has lasted for billions of years. The most terrifying region of this world, however, is the narrow, jagged line that separates these two realms, the terminator, or the twilight zone. This is the interface between the furnace and the tomb, a ring of perpetual dusk where the temperature gradient is so steep that it defies the traditional laws of meteorology. The difference in pressure between the superheated day side and the cryogenic night side creates a planetary vacuum of immense proportions. The hot, mineral-rich air of the day side is violently sucked toward the cold hemisphere, creating atmospheric currents of unimaginable ferocity. These are not merely storms. They are supersonic rivers of gas that travel at speeds exceeding 4,000 miles per hour, far faster than the speed of sound in our own nitrogen-rich air. These winds act as a conveyor belt for destruction. As they scream across the day side, they pick up the vaporized remains of the crust, the mists of iron and silicate, and carry them toward the dark. As this gas crosses the terminator and hits the wall of freezing cold, the minerals condense instantly. The result is a weather system that defies the human experience, a horizontal rain of molten glass and liquid metal, driven by supersonic gales that can strip the very surface from the planet. The debris of the disintegrating crust is flung across the planetary disk, sand blasting the transition zone with a grit of solidified rubies and sapphires. The sound of this place is a continuous, deafening roar, the scream of an atmosphere being forced through a thermal bottleneck at the speed of a bullet. While this internal chaos rages, the planet faces an even more existential threat from the outside. The parent star does not merely illuminate the world, it flays it. A torrential stream of protons and electrons known as the solar wind slams into the upper atmosphere with the force of a cosmic hammer. Because the planet is so close to the star, its magnetic field, if it possesses one at all, is often overwhelmed by the sheer density of the stellar plasma. The solar wind scours the upper layers of the atmosphere, ionizing the gases and dragging them away into the void. The planet is effectively hemorrhaging its mass, bleeding a long glowing tail of ionized gas that stretches for millions of miles behind it. This process of atmospheric erosion is a slow decapitation. Every second, hundreds of tons of matter are ripped away and cast into the interstellar medium. The world is being unmade by the very light that reveals its existence. It is a world of two faces, one burning and one freezing, both being slowly erased by a star that acts as both creator and executioner. The brutal physics of tidal locking ensures that the planet can never find balance. It can only endure as a fractured, lopsided remnant, a testament to the fact that in the deep reaches of the cosmos, the most stable configurations are often the most lethal. The terminator remains a site of eternal supersonic war, a thin line of screaming wind that marks the boundary between two different kinds of nothingness. Beyond the mechanical violence of the winds, a more insidious transformation occurs within the molecular structure of the atmosphere itself. In the crushing depths of such a supermassive world, the traditional boundaries of matter dissolve into a state of existence that defies common experience. On Earth, the human senses are accustomed to the clear separation of the sea and the sky, a distinct and reliable line where the liquid ends and the gas begins. But here, under the weight of an atmosphere tens of thousands of times heavier than our own, the very air is squeezed into a density that mimics the properties of a fluid while retaining the mobility of a gas. When the temperature and pressure exceed a specific lethal threshold, the distinction between these two states of matter vanishes entirely. This is the realm of the supercritical fluid, a high-energy crucible where the environment becomes a single, continuous, and crushing medium that is neither truly air nor truly water. A descent into this world reveals a nightmare of optical and chemical distortion. At the highest altitudes, the atmosphere is a thin, tattered veil of scorched hydrogen and helium flayed by the radiation of the nearby star. But as the descent moves deeper into the gravity well, the pressure mounts with a terrifying rapidity. The air does not merely become thicker, it becomes a caustic glowing mist that refracts the light of the sun into a kaleidoscope of bruised purples and hellish oranges. There is no horizon to speak of, only a gradual darkening of the sky as the density of the medium begins to approach that of liquid. The light from the star above is scattered and absorbed by the thickening fog, until the only illumination comes from the heat of the planet itself, a dull infrared glow that emanates from every molecule of the surrounding fluid, as if the very air were a dying ember. Within this thickening soup, the chemistry of the world takes on a lethal and alien character. High above the supercritical depths, the temperature remains high enough to keep metals in a gaseous state. But as the atmospheric currents carry these vapours into slightly cooler pockets, or toward the shaded terminator, the transition begins. Massive formations of iron vapour coalesce into dark metallic clouds that loom like mountains in the sky. These are not the soft, white clouds of a terrestrial afternoon. They are heavy, brooding reservoirs of liquid metal. When they reach their point of saturation, they do not rain in the way we understand. They weep. Great droplets of molten iron, white-hot and heavy, fall through the atmospheric layers. Because of the incredible speed of the planetary gales, these metallic rains are caught in supersonic currents and driven horizontally across the sky, becoming liquid shrapnel that can erode the very foundations of the world. Alongside the iron, the silicates, the fundamental components of common sand and glass, undergo their own terrifying cycle. The atmosphere is saturated with vaporized silicon dioxide, a mineral mist that permeates every cubic inch of space. As these vapours condense, they form a rain of molten glass. In the lower, denser regions of the atmosphere, this glass rain becomes a permanent and lethal feature of the environment. The winds carry these liquid shards at speeds that break the sound barrier, creating a scouring effect that reshapes the planetary crust in real time. The very air is a grinding wheel of liquid stone and metal, a caustic mixture that dissolves and displaces anything it touches. The chemical reactions taking place in this high-pressure environment are unknown to terrestrial science, creating complex short-lived compounds that exist only in the heart of this planetary furnace. As the descent continues, the transition to the lower depths is entirely seamless. There is no splash, no sudden change in density to mark the beginning of an ocean. The mist simply becomes so thick and so heavy that it can no longer be compressed. The observer is now submerged in a supercritical sea that may extend for thousands of miles toward the planetary core. This fluid is a solvent of incredible power, capable of leaching the minerals directly out of the rocky interior and holding them in a state of permanent suspension. It is a world of total immersion, where the crushing weight of the atmosphere above is indistinguishable from the pressure of the fluid below. The heat is a constant, suffocating presence, conducted through the supercritical medium with an efficiency that makes every inch of space a uniform, lethal temperature. In this environment, the laws of chemistry are rewritten by the hand of gravity. The molecules of the atmosphere are packed so tightly together that they begin to share electrons in ways that are impossible at lower pressures. The very nature of the chemical bonds that hold matter together is strained and distorted. This is not a place of solid ground and open sky, but a single, roiling metallic lung, breathing in the fire of its star and exhaling a mist of liquid stone. The silence of the deep is broken only by the rhythmic thrum of the planet's internal heat, and the distant, muffled roar of the iron storms raging miles above. It is a world that has turned its own substance into a weapon, a place where the air is a liquid, the rain is a metal, and the very concept of a surface has been erased by the overwhelming power of the deep. Far from the iron rains and the crushing supercritical depths, in the quiet, climate-controlled sanctuaries of terrestrial observatories, the first hints of these nightmares appeared not as images, but as flickering lines of code and stuttering graphs. The astronomers who first encountered this data sat in the dim, blue light of their monitors, their eyes red with the strain of a disbelief that bordered on physical pain. They were looking at light curves, the measured brightness of a star over time, searching for the telltale dip that occurs when a planet passes across the stellar disk. Under normal circumstances, these dips are subtle, predictable, and rare. But the signals emerging from the deep space surveys were anything but normal. They were looking at a star whose light was being interrupted every few hours with a rhythmic, violent regularity that defied the established boundaries of the possible. The initial reaction was not one of triumph, but of profound suspicion. The researchers stared at the transit timings and convinced themselves that their instruments were failing. They checked the cooling systems of the charge-coupled devices, fearing that thermal noise had introduced a phantom signal. They scrutinized the algorithms for software bugs, certain that a stray line of code was manifesting a fever dream of impossible physics. The mathematics suggested a world so close to its master that it was practically grazing the stellar surface, a world where the orbital velocity reached hundreds of thousands of miles per hour. It was a reality that seemed to belong to the realm of science fiction, a glitch in the matrix of a universe they thought they understood. They recalibrated their telescopes and waited for the next night, certain that the signal would vanish like a ghost in the morning light. But the signal did not vanish. It persisted across multiple observatories and different types of instrumentation. The mathematics remained relentless and unyielding. As the data was cross-referenced and confirmed, the moment of realization hit the scientific community like a physical blow. The fever dream was a physical object, a planet that existed in a state of terminal proximity to its sun. This was the moment when the arrogance of the old models finally crumbled. The astronomers were forced to accept that the universe was capable of producing configurations that were not just extreme, but seemingly contradictory. They were looking at worlds that should have been vaporized eons ago, yet there they were, stubborn and bright, casting their long shadows across the data. This realization led to the birth of a new and terrifying classification in the planetary lexicon, the Chthonian planet. The name is derived from the ancient Greek word for the underworld, a reference to the hellish conditions and the subterranean origins of these worlds. A Chthonian planet is the skeletal remains of a gas giant, a planetary corpse that has been stripped of its dignity by the relentless abrasive of cosmic radiation. These worlds were once like Jupiter or Saturn, bloated with thick envelopes of hydrogen and helium, orbiting in the cold, safe reaches of their systems. But through the process of migration, they were drawn into the inner sanctum of their stars, where the heat and the solar wind acted as a cosmic blowtorch. Over millions of years, the star systematically peeled away the gas giant's outer layers. The intense ultraviolet radiation ionized the atmosphere, and the stellar wind carried it away into the void, gram by gram, ton by ton. What remains is a scorched and naked core, the heavy metallic heart of a world that was once thousands of times larger than it is now. These are the ghosts of giants, rocky husks that have been forged in the centre of a gas planet and then exposed to the unblinking stare of a sun. They are composed of the densest materials, iron, nickel and heavy silicates, compressed by the weight of a former atmosphere into a state of extreme hardness. They are the ultimate survivors, the remnants of a celestial tragedy that has left them naked and alone in the fire. The discovery of Chthonian worlds forced a philosophical crisis within the scientific community. It suggested that the planets we see today are not necessarily the planets that were born there. The cosmos is a place of profound transformation and loss, where the very identity of a world can be erased by its environment. We began to look at every rocky planet with a new sense of suspicion, wondering if the stones beneath our own feet were once the core of a giant that had long since vanished. The data curves were no longer just numbers. They were the biographies of doomed worlds, the echoes of a violent past that we were only just beginning to decode. The astronomers, once the gatekeepers of a neat and orderly universe, were now the chroniclers of a chaotic and indifferent reality, staring into the dark and seeing the skeletons of worlds that had dared to fly too close to the sun. This was the true ghost in the data, the realization that even the most massive and majestic structures in the universe are subject to the slow, agonizing process of being unmade. This slow unmaking was not merely a physical process occurring in the distant reaches of the galaxy. It was a conceptual disintegration that took place within the collective mind of humanity. The scientific community found itself in the midst of a profound and unsettling crisis, a period where the very language used to describe the heavens was found to be inadequate. The textbooks that had served as the bedrock of astronomical education for a century were suddenly rendered obsolete, their neat diagrams of orderly orbits appearing as nothing more than a provincial fantasy. For generations we had looked at our own family of planets and assumed we were staring at the template for the entire universe, a predictable and harmonious clockwork where every gear and lever was positioned according to a divine or logical necessity. We believed that the cosmos was a place of stability, where the laws of nature were designed to produce environments conducive to the slow, steady march of evolution. But as the data from the deep continued to pour in, that comfort was stripped away. The imagery of textbooks being rewritten in real time is not a metaphor but a literal description of the upheaval. Chapters on planetary formation were excised, and new ones were penned in a state of intellectual vertigo. The core accretion model, once thought to be an absolute law, was demoted to a mere possibility among many. The neat divisions between rocky worlds and gas giants were blurred by the discovery of water worlds, lava planets, and the stripped skeletal remains of Chthonian husks. The scientific community had to grapple with a universe that refused to obey the rules we had written for it, a universe that seemed to delight in the subversion of our expectations. This crisis was rooted in the fundamental tension between the human desire for order and the universe's penchant for creating monsters. As a species, we seek patterns. We find comfort in the idea that the laws of physics are a set of guardrails that keep the chaos at bay. We want a universe that makes sense, a universe that feels like a home. But the discovery of these impossible worlds revealed a reality that is fundamentally indifferent to our sensibilities. The same laws of gravity that keep our Earth at a safe and life-giving distance from the Sun are the very same laws that drive a hot Jupiter into a lethal spiral or tear a moon apart to form a ring of debris. The laws of physics are indeed universal, operating with a cold and perfect consistency from the edge of the observable horizon to the atoms in our own bodies, but the outcomes they produce are infinite in their variety and often terrifyingly hostile to the fragile chemistry of life. The realization that the cosmos is a factory of extremes forced a profound shift in perspective. We began to see that the monsters we discovered, the worlds of iron rain, the planets of vaporized rock, the giants dancing in the fire, were not aberrations or glitches in the system. They were the system. The diversity of the cosmos was revealed to be a spectrum of violence, where our own existence was merely a quiet, improbable frequency in a much louder and more dangerous broadcast. We had to accept that the universe does not care for the standard or the typical. It explores every possible configuration of matter and energy, no matter how lethal or bizarre. The same thermodynamics that allow for the warmth of a summer day also allow for the supercritical fluids that crush and dissolve everything they touch. This philosophical crisis extended into the very heart of the search for life. If the majority of planetary systems were as chaotic and violent as the ones we are finding, then the pale blue dot we call home was not the inevitable result of a friendly universe, but a rare and lucky survivor of a cosmic gauntlet. The scientific community had to confront the possibility that we're living in a momentary lull in a much larger storm. The stability of our solar system, which has lasted for billions of years, began to look less like a law of nature and more like a miraculous coincidence. We realized that the architecture of the cosmos is not a cathedral built for our benefit, but a vast, churning laboratory where the experiments are often destructive and the results are frequently uninhabitable. The struggle to explain these worlds led to a new kind of science, one that embraced the chaotic and the non-linear. We began to study the physics of the extreme with the same rigor we once applied to the physics of the mundane. We learned to see the beauty in the violence, the elegance in the way a star strips a planet of its atmosphere, and the logic in the way a world can be turned into a molten eye. The crisis of the late 20th and early 21st centuries was not a failure of science, but a maturation of it. We were forced to put away the childish idea that the universe was made in our image, or according to our rules. We had to look into the abyss and acknowledge that, while we may understand the laws that govern the dance of the stars, we have no control over the music, and the music is often a discordant and terrifying symphony of fire and ice. The silence of the night sky was no longer the silence of an empty room, but the silence of a vast and crowded wilderness, filled with structures we are only just beginning to name and monsters we are only just beginning to understand. The clock of entropy ticks not in seconds, but in the slow, rhythmic decay of orbits that have been compromised by the relentless proximity of a star. For these doomed worlds, the future is not a vast expanse of possibility, but a narrow and inevitable descent into the waiting maw of their masters. This process of orbital decay is a silent, grinding consequence of the laws of motion and the dissipation of energy. As the planet orbits, its immense mass creates tidal bulges on the surface of the star, just as the moon pulls at the oceans of the Earth. But because the planet is moving so fast and is so close, these bulges do not stay aligned. They lag behind or lead the planet, creating a gravitational drag that acts as a constant, invisible brake. Every revolution, the planet loses a tiny fraction of its angular momentum, and in response, its orbit tightens. It is a spiral of no return, a journey toward a center that will eventually consume everything the world ever was. As the distance between the world and the star closes, the conditions on the planet transition from the extreme to the impossible. Matter is subjected to forces that can never be replicated within the fragile confines of a laboratory on Earth. Under the crushing weight of the star's gravity and the rising heat of the descent, the internal structure of the planet begins to fail. The crystalline lattices of the mantle are crushed, and the atoms themselves are forced into configurations that defy the standard chemistry of the periodic table. Electrons are stripped from their nuclei, and the interior becomes a degenerate soup of metallic plasma, conducting heat and electricity with a terrifying efficiency. This is the transformation of matter under the weight of a god, a state where the solid and the liquid are forgotten concepts, replaced by a dense, screaming fluid that roils with the energy of 1,000 suns. The concept of entropy, the universal tendency toward disorder and the dissolution of structure, finds its most violent expression in these final stages. The planet, once a complex and differentiated body with a core, a mantle and an atmosphere, begins to lose its identity. The tidal forces do not merely drag the planet inward, they begin to knead it like clay. The internal friction generated by this constant stretching and squeezing heats the core to temperatures that rival the surface of the star itself. Volcanoes of liquid metal erupt across the surface, and the atmosphere is flayed away in a continuous glowing stream of ions. The world is being unmade, its orderly layers mixed and scattered as it prepares to cross the ultimate threshold of planetary existence. This threshold is known as the Roche limit, a mathematical boundary in space where the gravitational pull of the star becomes stronger than the gravity holding the planet together. As the doomed world crosses this invisible line, the end comes with a sudden and catastrophic grace. The side of the planet facing the star is pulled with significantly more force than the side facing away, creating a tidal tension that exceeds the structural integrity of the rocks and metals. The planet does not merely break, it shatters. It is stretched into a prolate spheroid, a jagged egg of molten matter, before it is torn asunder into 1,000,000,000,000 fragments. In a matter of hours, a world that may have existed for billions of years is reduced to a ring of glowing dust and debris, a temporary halo of ruin encircling the star. This ring is the final monument to the planet's existence, a shimmering scar in the dark. But even this structure is subject to the hunger of the star. The fragments of the broken world continue to collide, losing further energy and spiraling inward. One by one, the boulders of iron and the grains of silicate dust fall into the stellar atmosphere. As they descend, they are vaporized in an instant, their constituent atoms adding a metallic pollution to the star's outer layers. For a brief moment in cosmic time, the chemical signature of the star changes, bearing the mark of the world it has just consumed. The silicon, the oxygen, and the iron of the planet are absorbed into the nuclear furnace, becoming part of the very entity that destroyed them. This is the eventual fate of every world that dances too close to the fire. It is a reminder that in an expanding universe governed by entropy, all structures are temporary. The stars themselves will eventually exhaust their fuel and fade, but the planets they harbour are often the first to go, sacrificed to the gravity that once gave them a place in the dark. The dissolution of these worlds is a macrocosm of the universal story, a transition from the complex to the simple, from the ordered to the chaotic. The legacy of the doomed planet is a handful of heavy elements scattered through a stellar wind, a ghost of a world that once was, now lost in the indifferent brilliance of a billion other suns. The spiral ends not with a scream, but with a silent integration, as the matter of the planet is recycled into the vast, churning cycle of the cosmos, waiting to be cast out once more into the void to form the seeds of something new, or to be lost forever in the increasing cold of the deep. The perspective shifts, withdrawing from the incandescent ruin of the dying world, ascending through the layers of the supercritical atmosphere and out into the clean, freezing vacuum of the interstellar medium. The inferno shrinks, the screaming winds fall silent, and the planet that seems so vast and terrifying is reduced to a mere speck of light, indistinguishable from the millions of others that populate the spiral arms of the Milky Way. From this vantage point, the galaxy reveals its true nature, a magnificent but utterly indifferent engine of gravity and time. It is a structure of such immense scale that the birth and death of 1,000 worlds are but the flickering of a candle in a hurricane. The Milky Way does not mourn the planets it consumes, nor does it celebrate the rare pockets of stability where life might emerge. It simply is, a vast, rotating disk of stars, gas, and dark matter, moving through the void with a cold mathematical precision that has lasted for 13 billion years. In this context of cosmic violence and chaotic migration, the existence of our own world, the Earth, appears not as a standard, but as a miraculous defiance of the odds. We live on a fragile sapphire suspended in a quiet corner of a suburban arm of the galaxy. While other worlds are flayed by radiation or crushed by the weight of their own air, our planet has enjoyed a period of relative tranquility that has lasted for more than 4 billion years. The nitrogen and oxygen we breathe are not the vaporized remains of our crust, but a gentle, protective veil that has allowed for the slow, intricate dance of biology. The stability of our orbit, the presence of our moon, and the shielding of our magnetic field are the silent sentinels that have kept the monsters of the deep at bay. We are the beneficiaries of a cosmic lull, a sanctuary of liquid water and soft sunlight in a galaxy that more often produces oceans of magma and rains of molten glass. Yet, the true miracle is not merely our existence, but our awareness of it. There is a profound and moving courage in the human spirit that compels us to look out into this hostile abyss and ask why it exists. We are a species of primates, tethered to a single rock, yet we have developed the intellectual reach to measure the temperature of a star 50 light-years away and to decode the chemical composition of an atmosphere we will never touch. We have looked into the dark, and instead of turning away in terror, we have sought to name the monsters we found. We have stared at the flickering light curves and the stuttering data, and through the sheer power of mathematics and curiosity, we have reconstructed the biographies of worlds that defy every law we once held dear. This quest for understanding is a testament to the fact that while we may be physically insignificant, our minds are capable of encompassing the entire architecture of the cosmos. To look upon a Chthonian husk or a hot Jupiter is to see a reflection of the raw, unbridled power of the universe, but it is also to recognize the value of the quietude we often take for granted. Every discovery of a hellish landscape reinforces the preciousness of our own temperate forests, our calm oceans, and our predictable seasons. We are the observers who give the universe a voice, the consciousness that transforms a chaotic ballet of dust and gas into a story of creation and destruction. The dread we feel when faced with the scale of the void is balanced by the exhilaration of discovery, the realization that we are part of a grand, unfolding mystery that is far more complex and beautiful than our ancestors ever dared to dream. The camera continues its retreat, the Milky Way now appearing as a luminous whirlpool of gold and silver against the absolute black of the extragalactic void. The individual stars, each perhaps harbouring its own family of impossible worlds, begin to merge into a single pulsing glow. Somewhere in that vast collection of light, 1 billion suns are burning, their radiation carrying the secrets of countless other worlds yet to be found, worlds of diamond ice, worlds of liquid carbon, worlds where the laws of physics are being tested to their breaking point. The light travels through the silence of the vacuum, a message without a recipient, a history without an audience, until it is intercepted by the curious eyes of a species that refuses to be intimidated by its own smallness. The narrative of the scary planet is not just a story of fire and ice, but a story of the human capacity to witness the infinite. We are the bridge between the small and the vast, the link between the fragile chemistry of life and the brutal physics of the stars. As the perspective fades further into the eternal dark, the sense of cosmic isolation is replaced by a sense of profound connection. We are made of the same stardust that forms the cores of the giants. We are governed by the same gravity that tears the planets asunder. To understand the monsters is to understand ourselves, for we are all part of the same restless, evolving universe. The screen begins to darken, the last traces of the galactic glow flickering like a dying ember, until only the silence remains. A silence that is no longer empty, but filled with the echoes of a billion worlds, each a testament to the infinite variety of the dark. The journey into the abyss does not end with a conclusion, but with a question, a lingering inquiry that will continue to drive us toward the light of the next star, and the next, until the very end of time.